Okay, let's get into our second example. That is section 7.5. We're still on page 7 of our notes packet. We're just going to do a second example here. I wanted to make each one of these its own video. I just think it makes it a little bit easier to digest in smaller pieces. So let's review. First, we have to label all of the parts of a right triangle. I like to start with the hypotenuse because it's always the side length that is opposite the right angle. I've labeled it 33 here. Next, I always like to look at where my angle of reference, theta, is. And in this case, my angle of reference is actually in that top corner. Usually I'm used to it being in the bottom corner, but that's okay. It's moved to the top corner here. I'm going to go ahead and I'm going to highlight the two side lengths that actually make this angle of reference because I think that makes it a little bit easier to see why theta is so helpful. One of those side lengths is always going to be the hypotenuse, but the other side length is going to be the adjacent side. In this case, our adjacent side is measured 19. So far, I know the adjacent side and I know the hypotenuse, which means I still have to label my opposite side. Unfortunately, I don't know any information about my opposite side, so I can't really do anything with that. I'm going to draw a line through it. At this point, I have all of the pieces of my right triangle labeled. I know where theta is, I know what my hypotenuse and my adjacent are, but I don't know the opposite side. So that leads me to the trig function, cosine. The cosine of theta is the same as the adjacent side being divided by the hypotenuse. So these are two equivalent ratios. I'm going to go ahead and replace what I know. The theta is going to stay where it is, but now it's in green. The adjacent side and the hypotenuse are the actual measurements I know here. The adjacent side is 19 and the hypotenuse is 33. So what I'm going to do is I'm going to use inverse trig, and that's going to allow me to undo the trig that's being done. I can't just divide by cosine on both sides. I need to use the opposite of cosine, which is inverse cosine. If I do that on one side of the equation, I have to do it on the other side because that's what the equal sign tells me, is I have to be equal, I have to do the same thing. So now, not only am I taking the inverse cosine of the cosine of theta, now I need the inverse cosine of the fraction 19 over 33, because this is the ratio of the adjacent side to the hypotenuse. So if I get rid of cosine on the left-hand side, I have to make sure I do the inverse on the right-hand side. This is where we actually end up ready for the calculator. I need to do the inverse cosine of 19 over 33. That whole thing is going to go into the calculator. I'm not going to change anything else about it. I can't simplify that fraction at all, and there's really no way to write that any differently. So once I have the whole thing written out, I tell myself this is ready to go into the calculator. You want to make sure always that your calculator is in degrees. Awesome, I am. And so now I look for the function menu. I want inverse cosine, make sure that the -1 is there as an exponent, and I like to close my parentheses, but you don't have to. We're doing angles here, so we're rounding to the nearest whole degree. 54.8, pretty close to 55. So I'm going to go ahead and call that theta is equal to 55 degrees. That's example 2.